Hi, this is going to be a video linking to sketching derivative curves. So I've got this GeoGebra file that I've created, which we're going to have a little investigate around with, and we're going to see what we think looks like is happening, and see if we can figure out how to draw a derivative curve. So we can differentiate. If you look in the top left here, function is x cubed plus 2x squared plus 1. When we differentiate that, we would get 3x squared plus 4x. So the graph we're going to draw is going to be the 3x squared plus 4x graph. We're not always going to be given the function, and we're not always going to be able to get a nice easy function that we can find out and then differentiate. So we need to be able to learn how to draw the curve without being given the equation. So if I just move this about here, we can see that my kind of orange triangle is tracking the gradient, and A is just a point on the line. M is the value of the gradient at the specific point A. So if I stick myself a tangent on here, we can see that the gradient at this stage is positive. The gradient here is tending towards 0. It will become 0 if I can get it accurate enough. Close enough there, so it's 0 there, so a stationary point would be a maximum point, and then we would have a negative gradient and we would reach another stationary point here. So the gradient would be 0 there, and then we would become positive. So if I go back to the beginning, and I'm going to click on my gradient function, so this is going to trace the gradient, and it's going to draw the gradient function on top of this graph. So we can see that the gradient here is positive 4.6. So this is up at about 4.6. And even when I'm in the negative part of my graph here, it's still a positive gradient, so it's the derivative graph is still going to be up here, probably off my graph actually, up in the positives. If I keep going, and I'm going to stop when I reach a pretty significant point. So here, I'm crossing the x-axis here with my grey line, which is my derivative curve, and that is when it's a stationary point. So it's a really key thing to see here that where there's a stationary point, it links up with where the derivative curve crosses the x-axis, because the gradient is 0, so the value of this would, the dy by dx value of this, which is the axis we're plotting it on, which I'll go into a bit more detail later, would be 0. So if we carry on, we can see, well, we're going to have a negative gradient coming up here, so it's going to continue going down. So a negative gradient here, my value of m is negative, so my gradient curve has gone into the negative quadrants of my graph, of my axis, sorry. And it's starting to become less and less negative now. So before it was minus 1.3, 1.33, and now it's moving back to minus 1.3, minus 1.2. So this graph is going to come closer and closer, and it's going to curve back up, and it should hit the x-axis at the same point I hit my stationary point, which is at the coordinate 0, 1. And we can see they line up nicely. And then from there, we can see that this graph, the green line, is going to have a positive gradient going forwards. So our line, our gradient curve would fall back into our positive quadrants. If I give this another go, so when you're using this, when you change the graph, just refresh it, otherwise that black line will not disappear. So yeah, let's have a look at this one that I've already got loaded up. So I've put this online for you as well. I'll show everyone the link so you can have a mess around with this and have a bit of practice. So I've plotted my tangent on here, my black line there, and I'm going to trace my gradient function. So right now, this is a really positive gradient, so I'm probably not even going to expect to see it, but it'll be somewhere up here. It's going to get less and less positive because we can see it's gone from really steep and it's kind of leveling out until we reach the top of my curve. So here we go, we start to see it, and when I reach the top of this maximum point, the top of this bump, which would be my maximum point, I'd expect this to be down at 0. Here we go, so roughly I've got it there. We can see that as this is at the maximum point, the gradient of this is 0, and then it's going to go negative because we're going to go downhill, and we're going to get less and less negative because we're going to start to flatten out. So the curve down here is going to start to move here. The minimum points of these of the gradient curve don't particularly link up to much. It's when the curve starts to level out and become less negative up here or less positive down there that it seems to do that, but they don't have too much significance here. And it starts to level out, and when I'm at 0, 3, I should expect it to be 0. Here we go. So it's back there. And then it's going to be positive for a tiny bit, and then it's going to go back down to negative. So I actually have a third stationary point, which would be roughly between these two clicks that I'm doing. I can't seem to quite find it. Somewhere between there. And then it's going to sharply go negative from there. It's an x4 graph, so when we differentiate it, we'd expect an x cubed graph, which is what this is looking like. So it seems like we're getting something along the right lines. So I'm going to look at some examples now, but that will be linked in the description of this and to you guys, so you can have a play around with that and kind of investigate for yourself. But let's have a look at what I've got here. So these are just 3 more things I plotted, and we're going to have a look. So key things to spot when you're plotting these is stationary point links up with where it crosses the x-axis. Stationary point links up where it crosses the x-axis. This point here would be an point of inflection, remember, because it goes positive and then it's positive afterwards. This would be a minimum because it goes negative and then positive afterwards. And we know how to check that, and we know how to do it through the second derivative and through checking either side of the first derivative. The way to draw these after that really is to think, well, negative gradient here. So this is going to be somewhere down in the negatives at the same time, and it's going to move up, and it's getting less and less negative as we move close, so it's going to get closer to my x-axis. Here I've got positive in this sort of stretch, positive and then flattening out to be 0, so that's how it's going to go up and then down. It's hard to tell how much up it's going to go. They're never that fussy when you actually draw them. As long as you've got the relative shapes in the right quadrants, you're good to go. And then after we cross here, it seems positive and it just gets more and more positive, so that's why it goes up and up and up and up and up. Looking at this one, this is just an x squared graph, so we'd expect 2x to be our gradient function. So we can see that they both, where this is a minimum point, this crosses the x-axis, and we've got a negative gradient here flattening out to be closer to 0, so this is why it's a straight line up going towards 0, and then at here we've got positive and getting more and more positive as we go along, so that's why this is just getting larger and larger as we go along. Having a look at this third one, we are going to first of all spot our minimum points, maximum points, points of inflection. That links up with this. That links up with this. So we know straight away by looking at this graph that we're going to have a coordinate on our gradient function here and here. First we just need to think, then next we just need to think, well, negative, so we're going to start somewhere down here. Then we go to positive and slightly less positive, so it's going to kind of go an up and down back towards the center here, and then we've got positive, so this is going to go up. I'm going to do a few examples from scratch, and I'm going to show you kind of a good way how to lay your work out. So this example here, first thing I would do, I know a coordinate's going to be there because it's a maximum, minimum point, or a stationary point, we could classify it as. I know there's going to be a coordinate here. and I know there's going to be a coordinate there. So my graph's going to go something like either through these three, like that way, or kind of like this way. I've got a negative gradient, so around these stages I'm going to have a point down here, because this would show a negative value of the gradient. Once I get past here, I've got positive, so I'll probably have some value up here. We're still positive, but we're getting less positive, so I'd probably have a value there, getting closer to 0, and I can see how it's probably going to loop up and down. This is negative, so I'm going to have a point down here. It's getting less negative because it's tending out towards 0, so it seems to have a point here, and then we're going to get positive and more positive and more positive. So getting the best kind of curved line you can through these. I'm drawing on a bit of a weird tablet, so it's difficult for me. It's easier with a pen and paper. But roughly, you want your differential graph to look like that. However, I wouldn't say this is the best way to do it. It's good to start like this because you can line them up quite nicely. But this graph that we've just drawn is dy by dx. And the graph that's in red is y. They are they do not exist in the same plane, so we actually aren't allowed to draw them on the same axis. Can we see that this is a y-axis? We would have to have a dy by dx axis up here for us to actually be able to draw this. So the best way to do it is to kind of have your original graph on the top, line up your axis perfectly, label it dy by dx, label up your x values. So we've got -4, -4, -2, -2, and then you can draw from there. So where we would have labelled that there, go down and label it here. Where we've got a stationary point there, instead of labelling it here, keep going down and label it on your other one. And instead of labelling it there, label it down here, and you can draw guidelines in between the two. I think this is the best way of setting it out. So here we've got negative, so give yourself kind of an arbitrary point kind of around here. Positive, so a rough point somewhere around there. We're going to get, we see we're going to go straight away, we're going to be like this. Yep. So then this is negative, so some kind of rough point like this, and we see that we're going to go down, back up towards 0, because this is going to get less negative, and then positive, so we're going to have some points up here, so it's going to keep going like this. We can see that my two graphs look roughly the same, but this is a better mathematical way of writing it. Final slide, just for kind of, I've got one more example. Maybe you want to pause it and have a go at this one yourself. I'm going to draw this on the same axes because I'm lazy. So maximum point, we would have something there. Point of inflection, we'd have a point there. This is positive and then less positive, so I know I'm going to start up here and I'm going to kind of work my way down towards my gradient of 0. This is negative, then we're going to have less negative. So you can always kind of just label your diagrams up like this if you want to. So it's going to do something like this. And then we get positive for a tiny bit. This is another stationary point here. So we're going to go positive again. And then we're going to go negative and negative. So we've got a slight positive point here, another point of inflection, another point, stationary point there, and then we're going to get negative, negative, so it's going to go up and down. It would be even better if we drew that on a separate axis. This final slide, just to kind of spark a bit of interest for year 2, can we tell what graph this would be? It's the sine graph, because we're fluctuating between 1, -1 and 180, 360. Hopefully we remember that. Let's have a go at drawing the differential graph for this. Something interesting might come of it. So first of all, let's label up our stationary points. We know we're going to go through these. So we're positive here, we're negative here, we're still negative down here, and we get positive, positive, we've got a positive gradient here, and we've got a negative gradient here. So let me kind of just put some points in there. So I said that this is going to be positive, so we might have some points like this. Said this is going to be negative, so we might have some points like this. Still negative here. Then once we get past this stage, we're going to be positive, so we might have some points like this. And I haven't done this section yet, but we're going to be negative, so we're going to be in this quadrant, and we might have some points like this. So if I do my best to draw these together, like so. Some of my points weren't very good, but that's okay. Do it in pencil, you can rub it out. And keep going down here. Have a think what that graph looks like if it was to be drawn better. To me that looks like the cos graph, which is quite an interesting thing that you might look into in year 2, but I'm going to leave it a bit of a cliffhanger there. And if you want to know anything more about it, you can always feel free to message me.